Hey everybody, thanks for joining me today. We're going to go over equations and the difference between what we're focusing on today and what we do over the course of like a month and a half in algebra is that instead of solving these equations, we're looking at the solutions, we are testing the solutions, we're sort of getting an idea about how these things really work. And so hopefully this turns out to be a really good preview for what's going to happen if you happen to be doing this class in order. Most Algebra 1 classes, Chapter 2 or Chapter 3, involve solving equations, and it's a chapter that seems to go forever because it's such an important concept. So hopefully this gets you a jump start and you figure out how this stuff works. Give yourself a good warm-up here. All right, so we start with example number 1 here, and we have to test a couple of different x values to find out if they are a solution to the equation. So you're plugging in -1 as the x value, and your goal here is to find out, did it check out, did it not check out? Is -3 plus 9 equal to 6, for example? Yes, it is. So that one checked out, so that means x does equal -1. Now, we still have to test out the other value because there are equations where more than one value can count as a solution. We don't deal with that a lot right away, but there are some cases. In fact, you will get one of them before you finish these examples here. So you've got 3 plus 9 equals 6, and that is just definitely not true. That is a no-go. 3 plus 9 does not equal 6. So we have a check for the first one, but we definitely have an x for the second. It is a no-go. X equals -1. So again, if you're paying attention here, the first solution was good. The second solution was not. All right, let's go to example number 2. This one, I tried to stump people a little bit by putting two different a values. And what that means is you have to take the solution that you're testing and you have to plug it in to both a spots. So you got to be careful with that. Let's go through here. You've got -10 equals -5 plus 5, which is definitely not -10. It's definitely 0. So that is a no-go. All right, let's try to test out +5. Let's see what happens. We've got 2 times 5 equals, plug it in again, and you get 5 plus 5. So that would give you 10 equals 10. That one checked out. That one looks good. So if we're going to write it out, we're going to say that a equals 5. All right, example number 3. I may or may not have warned you about this one earlier. If you plug in -2 for x, and then you square it and you add 2, we have to test that out, see if it equals 6. -2 squared is 4. 4 plus 2 equals 6. That one checks. I like that. That is good to go. Now, if we test the other one, now we're going to plug in a +2, we're going to square it, we're going to add 2, and we're going to put it equal to 6. And you get 4 plus 2 equals 6, which is exactly what we had over there before. That one checks out too. So this would be an example where both of the solutions check out. So you can't just say x equals -2, x equals +2. You can't just pick one of them. They both worked. So make sure when you write your final answer, you include both. Not just one, not just the second one, but both. All right, number 4. Is this equation true or false? So now you're just working out each side, seeing what you get. 20 minus 10 is 10. 5 minus a -5. Remember, the opposite of the opposite in this case becomes positive. That checks out perfectly. It is true. All right, I made examples 5 and 6 on purpose to identify some things that a lot of students seem to struggle with. So I just want you to pay attention here. Which one should we do first, multiplication or division? Most students say multiplication. They are wrong in this case, and the reason why is that multiplication and division are on the same level in the order of operations. There isn't one higher than the other in order. You have to do the one that comes first from left to right. So, in this case, you are actually expected to divide first and then multiply, which gets you something completely ridiculous like 64 equals 1. That is false, so we move on. All right, example 6, that's another one. A lot of people are going to go through, they're going to think it's true. It's not. Let me explain why. If the negative were inside parentheses, as in, let's say the problem had been written like this. You had a negative in parentheses and then maybe a plus out in front. If it was written like that, this equation would have been true, but it wasn't. In this case, because there are not parentheses, you are expected to do the exponent first according to the order of operations and then bring down the negative sign. So what we really have here is 19 minus 25 equals 44, and in case you haven't noticed, that is not true. All right, so that one didn't pass either. All right, example 7, identify the equation or equations that has a solution of x equals 9. So hopefully that'll actually go pretty quickly and pretty smoothly here. All we have to do is plug in the number 9 and give it a yes or a no. Is this good? Is this not good? Let's find out. So we start with the letter A. We've got 3 times 9. We're plugging in 9 into each one of these. Plus 7 equals 37. All right, 27 plus 7 equals 37. That doesn't sound right at all. That's because it's not. All right, let's try part B here. We've got a 9 that we're going to plug in right there. And then we also have a 9 that we're going to plug in right here. So 6 times 3 equals 9 plus 9. That sounds good because you have 18 on the left, you have 18 on the right. This one checks out. Letter B is good. Now, this is not multiple choice. There could be more than one correct answer. It's not like an A, B, C, D. You have to pick one. So that means we have to keep going. That's why it said or equations. You have to be ready to have more than one solution if necessary. And in this case, there is. And the reason why is because we've got letter C right here. If you plug in 9 right here, and then you square 9 right here, you've got 99 minus 18 equals 81. And sure enough, 99 minus 18 does equal 81. So the letter C checks out as well. All right, last but not least, you've got letter D. You've got 9 squared equals negative 9 times 9. So you've got an 81 over here, but then you've got negative 81 over here. So that did not go. That was not a solution. So equation B, equation C checked out. They had solutions of x equals 9. A and D did not. All right, last but not least, we have this section on solving equations mentally. Now, this is one of those I kind of want you to zoom right through. I want you to just think about things. Say it out loud if you're not in the middle of a test. 22 plus what equals 33? Well, I bet if I added 11 more to that, I would get what I needed. I know it sounds cheesy, but sometimes you're better off actually talking it out. All right, example number 9. 150 divided by what would give you 10? So you've got the number 150, and you're dividing it by a number, and you want to get 10 at the end. Now, what that means is you should have a 0 at the end, and the 15 sort of needs to cancel out. How about we divide by 15? And that makes pretty good sense. I know it says mentally, and this is not mentally, but I just want to demonstrate. If you did 150 divided by 15, the 15 sort of cancel out, become a 1. There's still a 0 at the end, and so that's where the 10 comes from. Now that's kind of a weird way of describing it, but I just wanted to explain to you what was going on. All right, last but not least, you've got radical x equals 12. So basically, you have to figure out what number you could take the square root of and get 12. Now this is one of those that a lot of students memorize in the earlier grades, so I'm not going to waste your time on it. I just want to make sure you recognize that if you did radical 144, sure enough, you would get 12 back. All right, thanks for joining me today. I appreciate it. Good luck the rest of the way.